The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
The atomic size trend on the periodic table. Now, firstly, what is the atomic size? If we come back here, the atomic size is going to be the size of the electron cloud of the atom as such. Now, we can keep that in mind as we work through this slide. If we see here, the atomic size trend on the periodic table increases across a period, right? Going from right to left, and it increases going from top to bottom as such. Now, one might ask, first let's consider the period here. Why does the atomic size trend increase going from right to left and not left to right? What is it that is that defining factor? Well, if let's examine what that could be using the second period. In the second period, and it comes back to our subatomic particles that we were looking at, in each one of these successive, so that lithium, beryllium, boron, carbon, nitrogen, and so on, in each one of these successive elements, there's going to be an additional proton in the nucleus of the atoms. Therefore, there's going to be a stronger attractive force on the orbiting electrons that pulls those electrons closer to the nucleus, causing a reduction in the atomic size. Now, in regards to the going down a group, as we see here, right? Yes, there's going to be additional protons and electrons, but the electrons, they're now going to be on the next quantum level, and because they're going to be on the next quantum level, they're going to be farther from the nucleus, and if they're farther from the nucleus, therefore there's going to be a dramatic increase in this atomic size. Now, don't worry too much about the quantum levels for now. We do cover that in a separate lecture. Thus, for now, just know that the increase going down a group is due to electrons being on an additional on the next quantum level. Okay, great. Let's move on to our next slide now, where we can do an example with regards to the atomic size to enhance our level of comfort with these types of questions. Great. Example, atomic radius. Now, you can pause the video and try it yourself, but for the rest of us, I'm going to continue here. The atomic radius of arsenic is larger than A, phosphorus, bromine, potassium, chlorine, B, phosphorus, bromine, mercury, chlorine, C, phosphorus, bromine, antimony, chlorine, or D, phosphorus, bromine, carbon, and chlorine. To answer this question, we could do two things. Firstly, we can call upon our periodic table. Oh, excuse me. I think we ended up going back too far back. And there we go. Okay. So we can call upon the periodic table, and this here is pretty much what your periodic table is the one that's going to be given to you is going to look like on test day. Now, coming back to our questions here just for a moment, if we see a reoccurring trend, that being phosphorus, bromine, and chlorine is given to us in all answers, and the only element that's different is potassium, mercury, antimony, and carbon. Thus, we can go ahead and highlight the following elements plus arsenic on the periodic table, and then we can see where they're situated with regards to the trends that we had pointed out in the preceding slide. Let's go ahead and do that. First, we'll highlight arsenic here. Then we have potassium here. We have mercury here. We have antimony here. We have carbon here as well. Now, just a word of caution. There are some discrepancies in the atomic size within the transition metals that we did not talk about. However, on the type of questions that you will be encountering, this isn't something that you should encounter on test day. Great. Now, let's go ahead also and just add the trends in as well. The atomic size increases to the left across the period and going down a group as such. Now, if we take a look at our first answer choice here, it's that being potassium, right? We see that the atomic radius of potassium is going to be larger than that of arsenic. Thus, A is going to be incorrect. A is not our answer. Now, with regards to arsenic, relative to arsenic, we see here for antimony and mercury, right, that because those electrons are going to be on subsequent quantum levels, they're going to be farther from the nucleus, thus the atomic radius is going to be larger for these elements here. Whereas for carbon we see we're moving in an upward trend, right? Thus, we can confidently say that for the answer choices given to us, that D will be the best choice, as our trends here, they predict that arsenic has a larger atomic radius, right, over carbon. Thus, D is our best answer as such. Thus, the atomic radius of arsenic is larger than phosphorus, bromine, carbon, and chlorine. Great, let's now move on to our next slide.